Okay, so what we're going to do today is we're going to look at the effects of concentration on the rate of reaction. So what we have is we have 3 bottles of peroxide, hydrogen peroxide, and they differ only by the fact that they're different concentrations. This is 3%, 10%, and 30% hydrogen peroxide. So what we're going to do is we're going to place those into a graduated cylinder. Notice the graduated cylinders are the same size and the volume of peroxide is the same size in all 3 cases. So we're trying to be as scientific as possible about this and make sure that all the variables are the same except for the one we're changing, which is concentration. Now, to that, what we're going to add is we're going to add some dish soap. All right? This will allow us to see the reaction. Now this might take a little bit, so I'm just going to invert these in here while I talk. All right, so we'll let the soap run down into the peroxide. Now, while we're waiting, what's actually going on is a very simple reaction. What we have is we have H2O2. That's a 2. All right? H2O2 is hydrogen peroxide. What actually happens is H2O2 reacts over time to produce H2O and O2. O2 gas. Now, that's happening right now. That's happening in these bottles. It's just happening really slowly. So what we're going to do is we're going to speed up this reaction. So I'm going to take my soaps out of here. I'm going to swirl each of them a little bit to make sure that they're well mixed. And what I'm going to do is I'm going to add a catalyst in the form of something called sodium iodide. Now the sodium iodide is not going to change the reaction. It's not going to be affected by the reaction. But what it will do is it will change the rate of the reaction. So it gives this hydrogen peroxide a way to react, a different pathway, so that it reacts more rapidly. So we'll put it into the 3%. And if you look closely, you can see that there are some bubbles forming. We're going to put it into the 10%. And we'll see a more rapid evolution of bubbles. And we'll wait for a moment, and you'll notice that the gas here is catching up with the other. If we stir a little bit, you'll notice the 10% is going a little bit faster than the 3%. Now, if I do this with the 30%, you'll also notice that this is an extremely exothermic reaction. And you'll notice the 10% is getting ahead. Now, just as a side note, obviously 30% goes far faster than 10% or 3%. As a side note, if we take a burning match, you'll notice the match doesn't go out, and in fact, it flares up when I put it into the bubbles. Because if you'll recall, those bubbles are oxygen gas. You'll notice now the 10%'s almost reached the top. You can see how fire flares up every time I put it into these. And the 3% is moving along gradually.